talk about finding the area between two curves. The rule is very straightforward. If here is one curve, and here is another curve, and you want the area, and one curve is f of x, and the other one is, say, g of x. If you want the area between the two curves between A and B, that is, if you want this area, it's very straightforward. It's the integral from A to B. It's always the top curve minus the bottom curve, dx. Okay, it's very clear that the blue function, f of x, is always above the g function, which is in red. Okay, now, that may not always be true. For example, if you were asked to find the area between A of B, between the two curves, and the curves happen to look like this, that is, you are being asked to, and the top function is f, excuse me, that's f, and the blue function is g. Between A and B is this area. But the problem is that, let's call this point right here C. Between A and C, the g function, the blue function, is on top. But between C and B, the black function, or f, is on top. So this is key. You have to graph these if they're not given, because you need to see which is on top. So between A and C, we have the blue function on top, better known as g of x. So I do g minus f, top minus bottom, dx, from A to C, and then I'm going to add on the integral from C to B, the area from C to B, and that's where f is on top. That's the portion where f is on top. Notice the first integral is A to C, where I have top minus bottom. That is, I'll get this area. Plus, now f is on top, f minus g. I'll get that area. If I add them up, I'll have the final answer. So you have to do the top minus the bottom. And sometimes that may alternate. Sometimes it might alternate. Sometimes they'll both be the same, maybe. Suppose I tell you f of x is x squared minus 6x, and g of x is identically 0. I want you to find the area in between. Now sometimes you'll be told what the A and the B are. This problem says, find the area of the given region. Well, if you were to graph the top one, if you factor out an x, you get x minus 6. So we now know the zeros. It crosses the x-axis at 0 from here, and from here I know that it crosses at 6. And since it's understood to be plus x squared, I now know the graph goes like that. Okay. The only thing is, I want to draw it in a different color than the axes. Okay, it's in blue now. So we have this. And the other curve, x equals 0, is this. Now basically, there's some area of the whiteboard that's trapped, can't get out. For example, if you were here, you can go out. If you were here, you can go out. If you were here, you can go out. But if you're in here, you're trapped. You're trapped. That's the area that we want. That's the area that we want. Okay? That is the area that we would love to calculate. And the smallest x value is 0. The biggest x value is 6. No matter what rectangle I put in here, the x's go from 0 to 6. So we're going to integrate from 0 to 6. The top function, which is 0, minus the bottom function, which is x squared minus 6x. Going to integrate that. Well, first, let us subtract the two. If you subtract these two functions, you get, there's the equal sign. You get negative x squared plus 6x. You get negative x squared plus 6x dx. And this is what we integrate. Integral of negative x squared, well, you make the power 1 more, you divide by 1 more, plus 6x. The power is understood to be 1, so you get 6x squared over 2. 6 over 2 is 3. So it's just 3x squared. And then you evaluate this between 0 and 6. When you plug 6 in, you get negative 6 cubed, which is, what do I want to say, 216. 216. Negative 216 over 3 plus 3 times 6 squared. 6 squared is 36. 3 times 6 squared is 108. Minus, now you plug 0 in. Well, you keep getting 0. 0 cubed is 0. Put a negative sign in front of it. It's 0. Divide by 3 is 0. X squared, 0 squared is 0. Times 3 is 0. This is just 0. Okay, so what you get is negative 72, because goes in there, negative 3 goes in there, negative 72 times, plus 108, which is 36. You'll get 36 square units of area. Whenever you do top minus bottom, you will never, ever get a negative answer. So if you get a negative answers, either you made a mistake integrating and substituting in their limit values, or you didn't do top minus bottom. Suppose you want to find the area between these two functions. F of x is x squared minus x, and g of x, well, that's 0. That's 0. Suppose you want this. Yeah, excuse me, that's this 3 up here. X cubed minus x. Well, first thing I would do is I would try to find the zeros. I will factor out an x. And I get x squared minus 1. And then I say, oh, that can be factored. And we get x plus 1 times x minus 1. So now I know my zeros. There's a 0 at 0. There's a 0 from that factor, a negative 1. And then another 0 at 1 itself. And since it's a positive x cubed, I know the cubic goes this way as opposed to that way. Okay, so that there is one of the graphs. And once again, it's in blue. Okay, and the other function is g equals 0. It's this function. So I'm looking for all the area that is trapped, can't get out. If you're here, bye-bye. I can go anywhere I want. You're trapped in here and in here. But now, the problem with that is the following. The problem with that is the following. What graph is on top now changes. The graph that's on top changes. For example, in this area here, the blue function is above the green function. So between -1 and 0, I do the blue function, x cubed minus x, minus the green function, which is 0, dx. And then I add on from 0 to 1, this area in here, where the green function is on top, minus the blue function, which is on the bottom, dx. Well, when we subtract the first time, we're subtracting 0. We get back x cubed minus x, dx. Plus, here, the 0 is gone. We get negative x cubed plus x. And here we go from 0 to 1. And when we integrate the first one, let me think a moment. Okay, we get x to the 4 over 4 minus x squared over 2. And this goes from -1 to 0. Plus, we integrate this, we get negative x to the 4 over 4 plus x squared over 2. But now we go from 0 to 1. Okay. Let me erase the top, and let's see what we get when we plug in these upper and lower limits. Okay, first, of course, we'll do this. Well, when you plug in 0, you'll get 0 minus 0. Minus, now when you plug in the lower limit, -1, you get a quarter minus a half. Okay, that's the first one. Plus the second one. When you plug in 1, you get -1/4 plus a half. Minus, and when you plug in 0, you get 0 plus 0. Okay, this here is -1/4. This is a 0. So we're taking away -1/4. That means we have a quarter. Plus, this is 0. If you take away a quarter and you add a half, you're really adding a quarter. So we add 1/4, and the answer is a half. And if you think about symmetry, you'd realize that this area down here is the same as this area. So we could have just found this area, which was a quarter. There it is right there probably. And then double it. So sometimes you can use symmetry, but you have to be crystal clear that it's symmetrically the same. And the fact that it was an odd function, x cubed minus x, if you plug in -x for x, you get -x cubed plus x, which is exactly the line above with a minus in front. That's what an odd function is. When you have an odd function, the area is going to be the same. You're going to have a portion that's above and a portion that's below. As long as the limits are favorable. And you'll become stronger on what I'm saying as time goes on. It's the top function minus the bottom function. You just can't do, oh, this is simple, I'll do f of x minus g of x always, and I'll get the right answer. Okay, let's do one more. Suppose I tell you that f is x squared plus 2x plus 1. This is f of x. And I tell you that g of x is 2x plus 5. Now, when I say you have to graph these, that's not necessarily true. The only time where if you have one graph and then another graph, and you want to integrate from A to B, that is, you want this area. The only time it changes, that is, it being the top one. Here, this is F, this is G. In this area here, it's going to be F minus G, and be the integral of that. But then here's F, and here's G. But then G's on top. The only time it's going to change where one being on top becomes the one on the bottom is where they intersect. It's where they intersect. In fact, if you know that they intersect at A and B and C, well, and we're going from B to C, we're going from 0 to 7. And the two curves cross at 0, two graphs cross at A, B, and C. So we can integrate from 0 to A, and we do f of x minus g of x dx. But you know what? Maybe g should have gone first. Now, if it turns out that g minus f is 7, well then, do you know that f minus g will just be negative 7? Okay, why? Because I factored out a minus 1. That minus 1 comes in front. And that's where you get the minus 7. Okay. So, if we just take the absolute value, so remember, it's always supposed to be positive. So if you just take the absolute value of your answer, that will cover your silly error. If you should have done g minus x, and you did f minus g, just take the absolute value. So we covered from 0 to A. And then we go from A to B. And we always do f minus g or g minus x, or doesn't matter. Just make sure you take the absolute value. And then it intersects at C again. So we'll go from B to C, f minus g dx. In case I have it backwards, I'll take the absolute value. And then I'll go from C to 7, f minus g. If you take the absolute value, it'll work. But this all does not equal the integral from 0 to 7 of f minus g dx with an absolute value. No. We want each piece being added separately. if this is 7 and this is negative 2, when you add them, if you calculate this area and you get 7, and you calculate this area and you get negative 2, well, what you mean to do is take the absolute value of these numbers and you get 9. But if you add them up first, you'll get 5. And then if you take the absolute value, you get 5, which is wrong. The answer should be 9. Okay, enough from that. I'll show you what I mean. We break up the integral every place the curves intersect. So the first thing is we want to see where x squared, where f equals g. Take away 2x from both sides. I'll bring the 1 over as minus 1. So x squared is 4. So x is equal to plus or minus 2. In other words, here's one graph. And the other graph will only cross at negative 2 and positive 2. It crosses once, and then it crosses twice. So we want to find this area. And it turns out that one function is always on top of the other. Which one it is, I don't know. Doesn't matter. What we're going to do is we're going to integrate from negative 2 to 2 of one function minus the other function. And just in case I wrote it backwards, I'll take the absolute values. Integral from negative 2 to 2. Well, when you subtract these, again, the 2's cancel, and you get x squared plus 1 minus 5 is minus 4. You get this function. And we want to take the absolute value in case I did it backwards. And then you get the integral, so I integrate. I get x cubed over 3 minus 4x. And this goes from negative 2 to 2. And whatever I get, I won't allow it to be negative. I put in absolute value bars. And then when you plug in 2, you get 8/3 minus 8 minus. When you plug in negative 2, you get negative 8/3 plus 8. Make sure that happens. And continuing to the left, 8/3 minus negative 8/3 is 8/3 plus 8/3, 16/3. Negative 8 minus 8 is negative 16. Okay, so you have 16/3 and you take away 48/3, which is the same as 16. You get negative 32/3. This is negative 32/3 absolute value. And then, of course, the final answer will be 32/3. Okay, I did this backwards. I should not have done f minus g. I should have done g minus f. But then again, I did not bother to graph it. I saved a lot of trouble by not graphing it. Maybe I don't know how to graph it. If I do know how to graph it, it takes a few minutes. I'm saying, it doesn't matter. It does not matter. Because if I do it backwards, I'll get negative 32 over 3 instead of positive 32 over 3. So I'll just take absolute value bars. Notice we never graph the function. You integrate from one intersection point to another. suppose I ask you to find the area bounded by this. Bounded means trapped. Y is equal to 1 over x squared. Y is 0. X is 1. X is 5. Okay. So, let's draw some of these, if not all of them. Y equals 0 is this line. That's y equals 0. X equals 1 is this right here. X equals 1. X equals 5 is somewhere further out. Say here. That's x equals 5. And you have some curve. You have some curve. There's your curve. Okay. We basically want we want this area and that area. Okay. That is, in this case, I would integrate, so let's call this B. I would integrate from 1 to B. And I would have one function minus the other. This is 1 over x squared, and this is 0 dx. And I would take the absolute value of this. In case it could have been that 1 over x squared could have gone like that. That is, the 1 over x squared is below y equals 0. Okay. Plus, now I'll integrate from b to 5, and it's one function on top minus the other one. But now, since I don't know if I have it correct, I'll take absolute values. That is, we just want to find out where they intersect. We are going to integrate from 1 to 5. Now, does these two graphs intersect? Does 1 over x squared ever equal 0? What you need to remember is that a fraction equals 0 only when the top is 0. 0 over 7 is 0. 0 over negative 4 is 0. 0 over 11/3 is 0. To be 0, the top is 0. But our top is never 0. It's always 1. So it's never 0. They never intersect. So we can just go from 1 to 5. But I don't know which graph is on top. Is 1 over x squared on top of 0? Or is 0 on top of 1 over x squared? I don't know. Nor do I want to find out. It's a pain. I don't even want to find out. I don't care. I'll do my integration. The level of difficulty will be exactly the same if I do it backwards rather than correctly. If I do f minus g or g minus x, the rate of difficulty will not change. Except if I get a negative answer, I need to say, oops. Alright, so 1 over x squared minus 0 is just 1 over x squared. But x squared is x to the negative 2. I did that because now it's easier for me to integrate from 1 to 5. I add 1 to the power, and I divide by that power, and I go from 1 to 5. First, though, I will say that we should clean this up. The x to the negative 1 can come in the bottom as x, and dividing by negative 1 is the same as multiplying by negative 1. That is, this fraction is negative, and I put the x on the bottom, and the 1's also on the bottom. I get negative 1 over x. And I go from 1 to 5. I hate this being negative. I can always change it to positive. I can always change the sign of this so long as I change the order of the limits. Instead of 1 to 5, 5 to 1. I type in the upper limit first, minus. I type in the lower limit second. And I get 4/5, which is positive, so it's 4/5. So the price I paid for not finding the curves, find out which curve is above the other, is I kept putting these bars. I kept putting the bars. Personally, I'd rather put the bars than figuring out which curve is on top of the other. If this would have been negative 4/5, I would have said the answer is 4/5. You don't have to find out which curve is on top of the other. Okay, now I want to make up a problem, so just give me one moment. So, suppose I give you these two functions. F of x is equal to x cubed minus 2x squared minus x plus 1, and the other function is just 1. Suppose you're given that. And you want to find out the area between the two curves. The first thing is, you have, the instructions are find the area between the two curves. So the first thing you have to do is find out where they intersect. Notice I'm not going to say to graph it equals 1. Take away 1 from both sides, the left side is 0. That is x cubed minus 2x squared minus x. That must be 0. After all, 0 plus 1 really equals 1. Okay, now I can pull out an x from here. I get this. Okay, so let's see how I really want this to be. Sorry about the delay. Suppose you had this. Okay, sorry. So now I'm ready. So let's start from the top. G of x is x cubed minus 5x squared plus 7x plus 4. And g of x is x plus 4. So I want to find out where they intersect. So I take f of x and I set it equal to g of x. And then I get it equal to 0. I bring the x over, so now I'll have 6x. I bring the 4 over, so I'll have no constant. And everything else stayed the same. Okay, if you take away x and you take away 4 from both sides, the right side is 0, and the left side will be x cubed minus 5x squared plus 6x, and then nothing. And now if you factor out an x, you get this line here, and then you can factor what's in the brackets. I want two numbers that multiply out to 6, but add up to -5. And those two numbers go next to x, and they're -2 and -3. So it equals 0 at 0, 2, and 3. Okay, basically, one graph looks like that, and the other graph, they touch at 0, they touch at 2, and they touch at 3. In fact, I could have gone like this. I just touch at 2, and then maybe I cross at 3. In any case, this is the area that I would just love to have. Okay. It turns out that the blue graph is always on top between 0 and 3. But I don't know that. This is just ridiculous. I don't want to do this. I integrate from 0 to 2, and then I integrate from 2 to 3. And I always do f minus g dx. F minus g dx. And in case I should be doing g minus f, I'll take absolute values, just in case. Now, what is f minus g? Well, it turns out it's right here. I mean, after all, this was f, and this was g, and I brought g to the left side, so I have f minus g. So this becomes x cubed minus 5x squared plus 6x dx from 0 to 2, and I'm going to add on the same stuff. From 2 to 3, take absolute value of them separately in case I made an error. And then the nice thing is both of these are the same, so the antiderivative will be. And the antiderivative is x to the 4th minus 5x cubed over 3 plus 3x squared. And it goes from 0 to 2, make it positive in case I need it, plus the same thing, this time from 2 to 3, absolute value. Okay, when I plug in 2 in here, I get 16 minus 8 times 5 is 40/3, plus 2 squared is 4 times 3 is 12. Minus, when I plug in 0, I get 0. That's the first result. Plus the second result. When I plug in 3, I get 81 minus. When I plug 3 in, I'll have 3 cubed, and one of them will kill off the 3 in the bottom. So it's really 3 squared, 9 times 5. 3 squared times 3 is 27. Minus, now I plug 2 in. But we just plugged 2 in. It's this. We just did it. All right. 16 and 12 is 28. 28 is 84? No. 60 84 thirds minus 40 thirds is 44 thirds. And since it's positive, I don't need the absolute values anymore. Plus 81 minus 16 is 65. 65. 25 minus 12, let's say minus 12, is 15. You add 15, now you have 80. And if you take away 45, you have 35. And then you have to take away negative 40 thirds. That is, you have to add 40 thirds. Well, this is 105 thirds. Plus 40 thirds is 145 thirds. Plus, well, since it's positive, I don't need the absolute value bars. 145 thirds. I was about to try to divide this by 3 to 145 thirds, but I won't because the denominators are common. When you add these two numerators, you get 189. And 3 goes into 16 6 times and into 9 3 times. The final answer is 63. And I never drew the curves. Okay, one last time to review. There are two situations that can happen. One where they give you, they say go from x equals 0 to x equals 5, and one where they don't. Where they say they don't, they just give you f of x and g of x. And they say find the area between the two curves. The first thing you do is you set f of x equal to g of x and solve. Okay, suppose, okay, so x equals a, x equals b, x equals c, x equals d. Those are the answers. Our solutions to 1. So what you need to do is you need to integrate from a to b plus, and then from b to c plus, and then integrate from c to d. And you either do f minus g, g minus f. It won't matter because you're going to take the absolute values. If you wrote f minus g there, you can do g minus f here. It doesn't matter. But I wouldn't, because now you're going to have to do two different subtractions. I would definitely be consistent. F minus g dx from c to d, integrate. Now, one of the nice things is suppose this antiderivative is some function, f of x. Well then, you're going to have to find f for b, and then you're going to have to find f for a. And the absolute value of that will be added to, now you have to find f for c, and you have to find f for b. Oh, no you don't. You have f for b, it came for free, and absolute value. And then you have to find big F for b, and then you have to find and take away big F for c. Oh, no you don't. We already found F for c. So some of the work has already been done in the previous step. If in step 2 you just had two values, you just have two values. You can't just have one value. You cannot just have one value. Why is that? Well, if I give you one curve and I give you another curve and they intersect in one point and only one point, well, there's no trapped area. There's no trapped area. If the curves went and met a second time, this here would be the area that they're talking about. Okay, so you only have A and B. So you'll integrate from a to b, f minus g dx. And in case you should have done it the other way, you take absolute value. If they're going to intersect at 2 points, one curve is always going to be on top of the other between the 2 points. Okay, it could be that you have this one curve and the other curve starts out here. Okay, to the right of this point, to the left of this point, this graph is on top of this graph. But to the right, it's still the same. Doesn't matter. We want the area that's tracked. Don't bother to graph these. I can't stress that enough. Okay? Even if you're really, at best, you're the best at graphing. But you don't need to. Worst scenario is you're not good at graphing, and then when you graph it to find out which is on top, maybe you did it wrong. Just take the absolute value. Now, the other case that can come up is they can give you one graph, they can give you another graph, and then they can give you two values. Okay? Here's A, here's B, here's a curve, A and B. Now, what happens between A and B, nobody knows. Okay, the first thing you do is you set f of x equal to g of x and solve. List the x values, from 1, which are between A and B. I don't care what happens outside of A and B. So, suppose that list was just C. Just C. So, you have A, C, and B. Okay, so you'll integrate from A to C, absolute value, plus you'll integrate from C to B, absolute value, and you'll integrate f minus g, or g minus f. Doesn't matter, because if you do it backwards, the absolute values will take care of it. If in addition to C, you also had D, you also have D, and D is bigger than C. So you go from A to C, you go from A to C, which is here, and then you go from C to D, which is now here, and then you'll integrate from D to B. F minus g dx, absolute value. So all you have to do is find out where they intersect. A lot of these inside the absolute value bars will be positive. That is, you didn't need the bars. Okay, but it doesn't matter if you don't need them. What's in here is 3 halves. Having the bar didn't really matter. It's 3 halves. When it's negative 3 halves, it mattered. You needed the bars. If it was negative 3 halves, you really should have done g minus f. But it doesn't matter. So you never ever have to graph these. I hope that's clear. If it's not, it's much better for you to keep watching this video and figuring out how I'm doing it, as opposed to giving up and saying, I'm going to graph it. Graphing is difficult and time consuming. My method, no graphing. Just put bars instead. Okay, that completes this section.